Ladies and gentlemen, our next speaker is a very good friend of mine, Werner Vogels, who is the CTO of Amazon.com. Werner is an amazing guy. He's the only person in the world who knows the number of rats in New York. He claimed there are 96 million rats in New York. He counted them personally. He knows at every minute where your packages are. He's responsible for all the packages which get lost in Amazon. He's very instrumental in Amazon Web Services, and he's going to talk about Werner against the machine. Ladies and gentlemen, please accept Werner Vogels.
Thank you, Yoshi, as always.
What is written here?
It's one of my customers gave me. It's called Werner against the machine.
What does it mean?
And I think at the back, well, it means that these days, no startup, no young business needs to worry about machines anymore. Everything has become software. Yeah, and so things that used to be hardware and constraints are now no longer constraints, because you no longer have to worry about hardware because everything has become software. Yeah. Today I want to talk about a few things. Yeah, so today was a day about IoT, which is of course extremely hot at the moment. But many of our customers in our cloud, mostly going to talk about the cloud division. Yeah, and so AWS, the Amazon Web Services. Many of our customers there have already been building IoT applications for a long time. And I'll talk a bit about that, sort of the general patterns that we see. And then I'll talk a bit about sort of the software challenges around building IoT and what are the kind of things that at Amazon we've built to make it easier for you to build IoT applications. And then I'll talk a bit also about one of the devices that we've built, the Echo. Don't know if you've seen that one. And I'll talk about the Alexa voice service and all the voice processing and stuff like that we do there. All of those are kind of patterns that you see coming back, and whether that is a mobile or whether it's an IoT, that actually the majority of the functionality of applications live in the back end, no longer live on devices itself. Where devices, especially if you talk about mobile, they're just a window into data and functionality that lives in the cloud. And in IoT, definitely, because the devices are often not really smart. And as such, most of the functionality lives somewhere else. So, and I call this beyond the fridge because, for a long time in the whole IoT world, the fridge was sort of the prototypical example. When your milk would run out, the fridge would reorder it. And actually, turns out the fridge is the wrong model for that. We had a company actually build a prototype trash can, because the trash can is the best place to reorder stuff. So what you would do, you would throw something in the trash can, it would scan the SQ code that's on the product that you've thrown in the trash can, and it would automatically reorder it, on Amazon, of course. Yeah? Unless you would kick it, then it wouldn't do that. It actually is a prototype that worked. But that's really one of the earlier days stuff. If you look at today, it's everybody saying, whatever, IoT is going to be massive. Probably every possible analyst is going to say that this is going to be huge. You know what? It is already huge, but it's going to be much bigger because there's a lot of innovation going to happen here. Yeah? Eventually, everything that will draw a current, can draw a current, will become connected. Yeah? And so there might even be lots of devices or lots of things that we use today that do not draw a current, but will become enabled like that. I'll have a few examples of that later. And so in AWS, many of our customers are already doing this. And there isn't an industry or there isn't a vertical that is not building IoT-driven applications right now. Yeah? And whether it is in health sciences where Philips, for example, is building his health suite where you can connect all the devices into, collect data, get let's say, analytics based on that particular data. Municipal infrastructure is a great example. There is the city of Chicago. The city of Chicago is building open source hardware, or has built already. You can find it on GitHub. It's open source hardware with lots of sensors in it about air quality, noise, traffic, pollution, all these kind of things. So you can go into GitHub, get the model for that, for how to build these devices, then you can mount them on light poles throughout the city. And then they've built software on that. It's called Smart City, I believe, Smart Things. I forgot exactly, but you can also get their software for free. It's open source software. So there's a lot of things happening in municipal infrastructure and hooking them up. We'll have some more examples there. Of course, everybody knows about the smart home. I'll be skipping that mostly. Retail, what we see is that, lots of instrumentation, and whether that is through video or audio or other type of tracking, people looking at how are individuals walking through stores, things like that. It's a big push of IoT in manufacturing, mostly around achieving better efficiencies and achieving more safety in that particular world. Agriculture is totally changing. John Deere, you know it well if you're an American citizen. These are these big agricultural machines that you see everywhere. All of those are becoming instrumented to the point that the farmer actually no longer leaves his home, but sits at home and plays what's called gentleman farmer. Yeah? Because every device throughout his whole farm, he can actually track from his iPad. So this automotive, all these other areas. Yeah, so of course, we've all seen all the consumer ones. I want to highlight a few. The guys from Consumer Physics out of Israel have built a very small sensor that you can actually put on any type of product or any type of organic product, and it will sense what is actually the composition of that product. They even say that you can put it above your food, and it will tell you what the calories are that are in that particular amount of food. So very cool devices being built. GlowCap is where actually medicine is being kept in, and especially for people who forget to take their medicine because they're elderly. That one helps you keep track of stuff. Yeah? Much of this is all about behavior modification. We all have these health apps on our phones. I at least have them, and they're very effective, as you can see. Yeah? But there's lots of those kind of things. But what's really exploding, absolutely really exploding, is the industrial Internet of Things. Yeah, where GE, for example, is instrumenting their gas turbines, where all of the data from the gas turbines flows into the cloud, where it's being analyzed to drive more efficiencies. Yeah, and actually, a 1% improvement of efficiency in these gas turbines means significant amounts of dollars for the electricity or the energy companies that are using them. Shell's dropping sensors in each of their oil wells. Tata Motors in India, 200,000 trucks on the road. They're all instrumenting these trucks because one of the biggest problems for them is trucks breaking down somewhere. And if you ever driven around in India, you know that this is a significant risk. And so for them, if they're able to do preventive maintenance on their trucks, they can actually drive costs significantly down. Philips here is called Philips City Touch. So they reinvented the way that street lamps are being used. Or these days, street lamps will all become LED lamps. And each of those street lamps will have a small GPS modem in them. And so as such, these lamps periodically report energy usage back to sort of the central place where you can actually then analyze energy usage throughout town. But you can also control these lights. Yeah, you can control the color and intensity of these street lamps from remote. So there may be a football match going on over here, and the train station may be over there, and you can create a different colored path through the city with your street lights to get fans back from the football stadium back to the train stadium. Construction is a whole other area that have never been connected and never had these kind of digital technologies that we can make available now. So now with all sorts of sensors in construction places, you can actually create, first of all, a great record about the concrete was poured at that particular temperature with that humidity, but also create all sorts of new safety products around it. One of the areas that is surprising to many, that is a hotbed of IoT, is sports. And of course, for some time already, we all know this whole story about Moneyball. By the way, it is a great book to read, not only because he played in the movie, because it's actually really a good business book to read about how you can use analytics to drive your business. And of course, there's also sort of augmentation around it. On one hand, you can get insight into a live match that's going on. But also, for example, Manchester City each year makes a data set available for everybody else to use about every player, every movement of every player, every touch of the ball that he did in all the Premier League matches. So sports is absolutely becoming data-driven. To the point that, for example, in basketball today, the decision whether to go for an offensive rebound or immediately retreat after a shot back to your own basket is no longer driven by conditions on the field, but by data analytics that is happening before it. Games are all being built on sensors that are in the clothes of all the basketball players and football players as well. It all goes to the extreme evenly. Some research have found out that if you track the heart rate of players that are on the field, players that really work well together have the heart rate go up and down in the same sequence. And if there's players whose heart rate is out of sync with the rest of the team, you might as well take them out immediately. So what you'll see pretty quickly happening is that the manager or the coach sits on the sideline with an iPad or another tablet in his hands, looking at the heart rate of the players on the field and makes decisions based on replacing them, no longer on what they're doing, but how their heart rate is going up and down. I'm not really convinced that that's a good thing, by the way. Yeah? Lots of things in consumer space as well there in terms of sports. These are socks that now are sensor and internet enabled. So what these socks do is actually look for runners have the real way in that they want to make a stride, the way that they want to run. So to improve your running, you can have these sensor-enabled socks that actually will tell you exactly how you're placing your foot while you're running and actually tries to optimize that. Recently, Intel and ESPN put these QE boards on snowboards to really figure out what are the G-forces that are happening on these athletes. And that was more to augment sort of the television environment. But now, all that information about G-forces and how these boards behave also drive a lot of innovation at the board manufacturers themselves, because they can use this data to drive new products. So this guy Sonos, this is a statement that they made some time ago, which clearly signals about the application space around it. Yeah? It's no longer the case that you can build a product that is just stable and that's what it is. Yeah? You need your applications that you build, or the devices that you build, or the systems that you build need to be upgradable and evolvable. Yeah? If Sonos would have been what they were 10 years ago, that would no longer meet modern requirements. So their devices have become a platform for new functionality instead of staying the same. Now, how do you do that in a world where most of these things are hardware? It's by focusing on the software side of things. Yeah? And definitely, I think car manufacturers are all thinking about this. The car is becoming a platform that will be continuously upgraded. I think Tesla has already demonstrated some of this. But these things, the functionality of these cars, at this moment if you buy a car, the functionality of your car stays the same forever. Yeah? But this car becomes a platform that will evolve over time with all sorts of new functionality. It's also what we will expect. Yeah? So why is this sort of mesh between the device world and the cloud so important? Yeah? Because in essence, many of these devices have just really limited capabilities. Yeah? And so quite a few of these devices, especially in the industrial Internet of Things, just generate data. They just generate sensor information. And the true intelligence, moving from data to knowledge, happens actually in the cloud, not on the devices itself. Yeah? They may have constrained resources, they can't even store things, they have no compute capabilities. Or they may even be in constrained environments. When I talked earlier on about Philips CityTouch with this GPS modem in these lamps are not continuously connected to the mother base. Yeah? There's no need for that. They're just sort of an ET phone home model where periodically they will connect the home base, report their information, and then pick up instructions for what they need to do. Yeah, and so there's lots of reasons to actually do these kind of things, because there's lots of combinations, and especially around security, by having an extended environment into the cloud where you can actually control the devices and control identity and security and secure communication with the devices. But building this stuff is hard. If you've ever tried to, in this whole world of all sorts of new different types of devices, protocols that are still in flux, it's pretty hard to build this kind of stuff. Yeah? To make this stuff scale is not trivial. How to handle millions of devices that generate billions of messages. All of this stuff is pretty hard to do. And as such, when we saw all of our customers that had already been building IoT applications on our platform, we realized what kind of the things they really wanted to do. And we built a platform for them. So that thing is called AWS IoT, this Amazon Web Services. And so that really is intended to solve the problems around the space of IoT. In terms of security, in terms of scale, in terms of protecting sort of offline devices and things like that. Yeah. So let's take a quick look at what sort of the components are in AWS IoT. Of course, there's a device gateway. That's a place where all these devices talk to. Highly scalable, millions of devices, billions of messages can flow through there. Use a pub/sub model there to do this. We deliver device SDKs for all the, together actually with many of our partners, for all the different platforms that are out there. And most importantly there, we give the ability for you to sign X509 certificates to these devices, such that you can uniquely identify the device, knowing what the device is, and actually have encrypted and secure communication between the devices and the gateways. Now, for many, this is extremely important. Yeah, and I want to hammer this every time in every presentation that I do. If you have sensitive business data, if you have what even looks like personal identifiable information, and many of these device data may be that, you have to encrypt your communication and you have to encrypt the data that you actually are sending. Yeah? It's just good security hygiene. You just have to do it. So we provide this out of the box for this environment. Then we have a rules engine that makes it very simple. You have information flowing back from your sensors, and you have a simple rule engine where you can say, if temperature goes over X, do this, open the window. Yeah? Very simple things, because much of that device work is simple like that. Or the rules engine may be, if it's a one-way street just collecting data for later analytics, it might be the rules engine say, if data comes from this set of devices, store it in that particular database. Yeah, so it connects with other Amazon services, but also third-party services like Twilio or other things you want to call home based on a particular occurrence happening in your device. Let's say, temperature is over 80 degrees, which means that you want to send an SMS message or you want to make a phone call to somewhere else, you connect it to Twilio. So most of your devices actually will not be online all the time. Yeah, and as such, we build something called device shadows, where if you want to build your applications, you can pretend that the device is online all the time. You just communicate with the device shadow. Yeah, and so here, as I said earlier, temperature may go over a certain number of degrees. It means that you want to open the window. The application may actually make that decision, writes that to the device shadow, and whenever the window opener device comes back online to check whether there's instruction for him, it will check with the device shadow to see what its instructions are. So it makes building applications much easier, because there you don't need to worry about disconnected devices. And it makes it easier also to have these device SDKs. The devices no longer need to worry about where they need to pick up instructions for what to do. So all of that is the AWS IoT environment. One thing there is also in there is a registry, where you register your devices and where you can go, for example, in the pub/sub model, say, give me all, for example, trackers here in this room. Yeah, tracker is this device that you can carry with you on things that you don't want to get lost. So you can actually make these sort of simple statements, simple queries about which devices are here in this room and that are accessible by me or managed by me. Give me everybody's temperature in this room, things like that. So all of this actually works really well for it. We see a whole range of new type of applications being built, because now no longer, if you want to build IoT applications, you need to do all this stuff yourself. Yeah? Makes it pretty easy. Now let me take one other example. of this, the cloud augmenting a device. How many of you have ever seen an Echo or know about Echo? Or have one? Well, you have one. No, in Europe, that's a bit more touchy thing. But many of you may have seen it. So Echo is a device that Amazon has built. It's a consumer device. Sort of your personal assistant in home. It's got an always-on set of microphones in there. And what you do, you just say, Alexa, play Foo Fighters radio from Werner's Pandora. It goes out to Pandora, connects to one of my radio stations there, and then plays it. And so, or you can say, turn on the kitchen lights. Because it can connect to many of your home devices. And so this is a world where this device actually, as smart as it is, most of that smartness doesn't live on the device. The device is actually limited capable. It can do voice synthesis. It can do beamforming on the multiple microphones that are on there, and it can play music. Or it has a really good sound system. That's all that's on the device. All the smarts of this device live in the cloud. And so what you have there is what's called the Alexa voice service. This is actually a voice service that's not only available for the Echo, it's actually available for you and everybody else that wants to build voice-enabled applications. And the voice system in this is actually really, really good. Really waited with launching this until we've had a service where it's very natural to talk to. Now, I think if you look at the early days of search, and where we've all grown up with, when we go to search engine, we use this strange language, this sort of keyword language that we've all grown up with. Nobody actually naturally interacts with a search engine. But we really wanted this to be, voice is a very natural way of interacting. So, Alexa, tell me where Kim's backpack is. If you've lost it, you don't know, you can find it. And we'll come back with you using Tracker to say, oh, the backpack is in Kim's bedroom. And stuff like that. So all the functionality of that lives in the cloud. So what's in there, the device synthesizes the commands, goes into the Alexa voice service. It makes use of machine learning and other type of things to figure out what is the intent here of the command, and then goes out to what's called skills. And these skills are either developed by Amazon or they're developed by individuals. The Alexa Skills Kit allows anybody to develop applications that are voice-enabled. And it's not just the Echo device. It is actually, for example, working with quite a few car manufacturers that are integrating Alexa voice service into their environment. And where you can do, for example, you drive home with your car, and you can tell the car, say, when you're getting home, you can do things like, Alexa, put on the home lights, or turn on the heating, or things like that. So lots of protocols there that are actually integrated in that way. You no longer have to take care of. And so there's then the capabilities in there and drive some of the skills. So these skills are what it's all about. And so we developed a set of skills ourselves that come with the device. But in the past, let's say, 6 months, we've seen a true explosion of all sorts of different skills happening, where the manufacturers or where the service providers do this themselves. Uber, for example, built the integration into Alexa themselves. The same goes for Spotify. No longer it is us as a manufacturer of the device that has to provide you with all this functionality. It is the players themselves. So you can say to the Uber, you can say, Alexa, send an Uber to my home. And it will actually interact with the Uber service to get a car to your home address. Or integration with Spotify and things like that. So those are all sorts of skills that everybody can integrate. The Huffington Post can do news or top news. So tell me, Alexa, give me the hot news from the Huffington Post. And that will trigger an application that is built by the Huffington Post themselves. Makes it very simple to do. The Alexa Skills Kit is what you use. And then there is a whole set of skills that we've built in ourselves. Quite a few of those. So let me just take an example here. You register with this service a number of what we call utterances. And you don't need to be very specific, because the machine learning part of this will figure out what all the variances are on what you want to listen to or where you want to have your application triggered by. For example, this is a get horoscope one. So someone might tell you, give me the horoscope for Libra, and if you registered your skill like that, it will be triggered when someone says that. Yeah, the same, we have a number of things integrated in there that are sort of standard, because it requires a bit of special processing. One of them is your smart home control, where you can do things like switch on the kitchen lights, turn on the music over there, things like that. And there's also a discovery mechanism. You don't actually have to tell Alexa exactly which devices are in your home. You can just tell Alexa, say, discover all the devices in my home. And then it will go out on your network to connect to the different device gateways that you may have. Yeah, and then it automatically adds things like kitchen light and porch light and things like that to them. So why do you do this? Is because I hope that shows us an example that even though the device is a great device, the true intelligence of these devices, all live in the cloud. And you can actually build beautiful, wonderful applications, whether it is analytics or whether it's control applications, by making use of these cloud services. Also, working together with many of the starter kits that you know in the IoT space. All of them come with SDKs and have deep integration into the IoT system, so you can make use of these boards to drive this. Great set of processors, lots of innovation that you can do by starting off with this set of devices. If you want to learn more about this, just outside, if you just come outside of the venue there is the AWS booth. Go talk there, go talk about IoT, go talk about Alexa and all the other cool services that we have in this space, or for example in the whole mobile space, mobile development space. Very cool stuff where you can really focus on building your applications. No longer need to think about the infrastructure for IoT or for mobile. Yeah, and as such, this is such a cool and exciting space. Yeah, mobile as well as IoT, as well as voice. Yeah, and there's never been a better time to innovate and to build applications in this space. Yeah, we really hope that providing you with this platform, you can start building really amazing stuff without having to think that much about the infrastructure in it and how you have to do security or how you have to do scalability. All of this stuff comes out of the box for you. So with that, go build. Thank you.